In question 4.2, we are given a cracking reaction and a few questions related to it. This is the reaction. The reactant is decane and alkane. It is undergoing cracking and is broken into two molecules of compound Q and C4H10. Both products are gases. C4H10 has the general form CnH2n plus 2, where n equals 4, and so we know we are dealing with an alkane. This is its full structure, and so we have butane. We need to define cracking. Cracking is a type of reaction under high temperature and pressure where a large hydrocarbon molecule is broken down into smaller, more useful ones, usually an alkane and an alkene. Before we go on to the next part of the question, let's figure out what compound Q is. We start with 10 carbons and 22 hydrogens in decane, and when it is broken apart, it loses a butane, C4H10. What is left are 6 carbons and 12 hydrogens. But the equation tells us there are 2 molecules of compound Q, and so we need to divide C6H12 by 2, which gives us C3H6. This is the formula of compound Q. It has the general form CnH2n, where n is 3, and so we can deduce that compound Q is an alkene. Now a 3-carbon, 6-hydrogen alkene is propene. Next, we are told this mixture is bubbled through bromine water. Bromine water contains dissolved molecules of Br2, and we need to give the observation. Bromine molecules in bromine water make the solution an orange-brown color. Now both propene and butane in the mixture of gases could potentially react with the bromine in bromine water. If butane were to react, it could only undergo substitution, as alkanes are saturated, and so, in the presence of halogens, undergo substitution. However, this would only occur if there was enough energy supplied, because alkanes are very stable and resist many reactions. UV light would supply enough energy for a substitution to occur. Substitutions are generally slow. But the question says that the room is dark, so there is no UV light from the sun, so the alkane will not react with the bromine water, or at the very least, we could say it would react very, very slowly. However, because alkenes have a double bond, these can open up and add on 2 bromine atoms, forming a saturated compound. This is an addition reaction. Addition reactions happen relatively fast and do not need UV light to occur. The product, which in this case is 1,2-dibromopropane, is colorless. So the observation will be that the color of the orange-brown solution fades as the reaction proceeds and the bromine molecules in bromine water are added on to propene to form a colorless product. Next, we must give the structural formula of compound Q. Here it is. We already deduced that the compound is propene. Finally, we must say which reaction is faster. We have seen that propene, which is compound Q, will react faster than butane, as it is unsaturated and so is more reactive, and can readily undergo addition reactions by opening up its double bond.